Hello. So we start this chapter, plane wave at boundaries and dispersive media. We have to finish first 4 topics, and we have just started subtopic number 5, which is plane wave reflection at oblique incidence angle. Okay. So first of all, what is the difference between normal incidence and oblique incidence angle? We have already discussed in last lecture. So here, if electromagnetic wave is propagation in z direction, okay, or you can say that here this electric field or electromagnetic wave is directly perpendicular to z is equals to 0 plane. Okay, so this wave is perpendicular, so it is known as normal incidence. And if wave is not perpendicular but it makes some angle which is theta I is incidence angle, so it is known as oblique incidence. Okay, so theta I is incidence angle, theta R is a reflected angle, and theta T is transmitted angle. Okay, for respectively incident wave, reflected wave, and transmitted wave. Okay, so based on that we have to derive Snell's law. So in last lecture we have to derive two equations for Snell's law, which say that incident angle is exactly equal to reflected angle. So whatever here the incident angle it makes with z axis, we will get the same reflected angle back. Then next is n1 sin theta I is equals to n2 sin theta t, where n1 and n2 is known as refractive index of first medium and second medium respectively, and n1 is under root of mu1 epsilon 1 and n2 is equals to under root of mu2 epsilon 2. Okay, so keep in mind n is a refractive index, it's not an intrinsic impedance. Actually intrinsic impedance equation is under root of j omega mu sigma plus j omega epsilon. It's an intrinsic impedance, but n is refractive index of medium. So we will get these two Snell's law equation. First is theta is equals to theta, and second is n1 sin theta is equals to n2 sin theta t for first medium and for the second medium. Okay, so now based on that we discuss about there are the two types of polarization of wave. Okay, so now today we start polarization of wave. So there are the two types of the polarization. First is parallel polarization and second is perpendicular polarization. So first of all we have to discuss about the parallel polarization. Okay, so this is the actually this one is a subtopic of plane wave reflection at oblique incidence. Okay, so first of all, what is parallel polarization and what is perpendicular polarization, that we have discussed. So first is parallel polarization. What polarization is indicate? Polarization is indicate is nothing but actually is a direction of electric or direction of magnetic wave or field. It is known as the polarization in a general case. Okay, so here what we have to do, we consider the same thing. Okay, that we have to consider this one is my x-axis, it is z-axis, and where is y-axis? Y-axis is exactly perpendicular. Okay, so this is my y-axis. Now we discuss here oblique incidence. Okay, so which one is the incident wave? So this one is my incident wave. Okay, this one is a reflected wave, and the some portion is transmitted, so it's a transmitted wave. Okay, so in a simple words I have to say that it is EI incident wave, reflected wave, and transmitted electric wave. Okay, we have just focus on electric wave. We will do the similar calculation for magnetic wave also. Clear? So incident, reflected, and transmitted wave. So what actually it indicates? It indicates is propagation direction. Okay, so here we consider which plane? We consider x z plane. Okay, so this xz plane, so this one is nothing but my which plane? It is z is equals to 0 plane. Okay, so at z is equals to 0 plane, it makes some angle. So incident wave is makes theta I angle, this reflected wave makes theta R angle, this transmitted wave makes theta T angle. Okay, and this one is indicate the direction of propagation. So incident electric wave is propagated in which direction? In both x and z direction. Similarly, the reflected electric field in x and z direction, and the direction of means the propagation direction of transmitted wave is also x and z direction. Okay, see here the propagation direction and field direction both are different. Okay, that we have discussed in our last theory. What is the generalized equation of electric field? E of zt, which is a function of space and time, is equals to E0 cos omega t minus beta z into ax. Okay, so here what axis indicate? Here axis indicate the direction of electric field. Okay, and what z indicate? Z is indicate direction of propagation. Okay, that means is a the propagation direction means the wave is propagating in this direction. The wave is transpose some distance. Okay, the wave okay, it contains some distance in the z direction. Okay, so actually the z is the propagation direction. That means the z direction the wave is propagating. But what is the direction of E? The direction of E is x direction. Okay, so here the propagation direction is x direction, but what is the direction of E exactly? Okay, so actually it is based on the polarization. Okay, so here we discuss about the parallel polarization. Parallel polarization is indicate that electric field direction is parallel to the xz plane. This plane is known as which plane? Xz plane. So xz plane is known as plane of incident. Okay, so electric field is parallel to this xz plane. Okay, whatever the electric field, either it is incident, reflected or transmitted electric field, but electric field should be parallel to the xz plane. So it is known as parallel polarization. Okay, so here I will give an example so we will get the easy understanding. Okay, suppose I will draw a 2D representative. Okay, so suppose this one is my x-axis, it is minus x-axis, y-axis and minus y-axis. Okay, now I have to draw vectors. Okay, so I will draw this vector. Now what I have to say about this vector? This vector is in which direction? In positive x direction, but this vector is present in xy plane. Okay, what about this vector? This vector is pointing in minus y direction, but the vector in which plane? Xy plane. What about this vector? This vector in the minus x direction, but it is the vector still present in which plane? In xy plane. Okay, similarly what about this vector? The vector in the positive y direction, but the vector in which plane? The vector is present in the xy plane. Okay, because I will draw the 2D representative. It's a 2D representative, x and y. I have to consider only x and y direction. Okay, so all the four vectors are present in xy plane. So I have to say that this all the four vector is parallel to my xy plane. Okay, these four vector are parallel to my xy plane. Now I have to take another vector. For example, I have to consider this vector. Okay, this blue pen is nothing but my one of the vector. It is pointing out. Okay, so I have to represent like this. So pointing out. Okay, if suppose it is pointing in, so this is a cross, so it's a pointing out. So what is the direction of vector? The direction of vector is z direction. Okay, so this vector is perpendicular to xy plane. It is not parallel to the xy plane, but it is perpendicular to the xy plane. Similarly, what about this vector? This vector is minus z direction, so this vector is also perpendicular to the xy plane. So it is known as perpendicular polarization. Okay, so now I think it should be clear for you that what is the meaning of parallel polarization and perpendicular polarization. So in parallel polarization, what we have to consider? We have to consider that electric field is parallel to my xz plane. Okay, so here I have to consider the direction of electric field. So this one is the direction of electric field. Okay, it is incident electric field. Okay, which one is the reflected electric field? So this reflected electric field. And which one is the transmitted electric field? This one is my transmitted electric field. Okay, now what about the magnetic field in all cases? Okay, so here we consider the magnetic field in positive in positive y direction. So it is magnetic field which is Hi. Okay, here the magnetic field is reverse because the propagation direction is reverse. So here the magnetic field is present in negative y direction, and here the magnetic field is present in again in positive y direction. Okay, so this Ei component, Er component, and Et component. Okay, so similarly it is Ki. What is Ki? Ki is propagation vector that we have already discussed in our last lecture. Kr, okay, reflected propagation vector, and Kt, transmitted propagation vector, that we have already discussed in our last lecture. Okay, and we have applied the boundary condition for that also. Okay, clear. So now I have to write the equation for Ei, Et, and Er, incident wave, transmitted wave, and reflected wave. Okay, so now first of all I have to write the equation for incident wave, then after reflected wave, and finally transmitted wave. Okay, so what should be the equation? First, equation for incident wave. So Ei is equals to, I have to write in this way, it is EIO. Okay, I have to use this equation, E0 cos omega t minus beta z. Here Ax is the direction of electric field and Z is the propagation direction. Okay, so actually here I have to apply some mathematics. Okay, so this vector makes some angle. Okay, so here is a theta I angle. Okay, so it's an incident angle. Theta I is nothing but my incident angle. Okay, it makes theta I. So here, which one is the theta I? This angle is also theta I. Okay, how to apply just simple mathematics. Was this mathematics says here, if there are the two parallel line and if I draw another line, so whatever the angle here it makes, suppose it is theta, here it makes the same angle theta. Okay, so I have to apply the simple mathematics front up. So this vector, this Ei vector, okay, here the angle is theta I. So similarly here angle is theta I. What should be this angle? This angle is 90 degree minus theta I. Okay, this angle is 90 degree minus theta I. And what about this angle? This angle is also theta I angle. Okay, I will draw this picture so you get clear understanding about it. I have to zoom this portion. Okay, so incident wave, I have to zoom this portion so you get the clear understanding about it. This one is my Ei. Okay, okay, so okay, now it's correct. So here this angle is which angle? Theta I angle. Okay, so this angle is 90 degree minus theta I. If it is 90 degree minus theta I, so this one is 90 degree minus 90 minus theta I, so this again theta I angle. Okay, so now this vector has combines the two parts, first and second. Okay, what is the value of this vector? It is nothing but my Ei. Okay, so this component is Ei sin theta I and this component is Ei cos theta I. In which direction? This one is x direction and this one is in the z direction. So I have to write in this way, EIO, okay, is maximal is EIO cos theta I in which direction? In x direction, plus second component is EIO sin theta I in which direction? In z direction. Okay, so I have to write simple in this way, EIO in the bracket it is cos theta I AX plus sin theta I AZ. Okay, so which component is parallel to x-axis? Of course, Ei cos theta I AX is parallel to, is in the same direction of x. And which component is parallel to the z-axis? EIO sin theta I AZ. Okay, so we will do the similar calculation for ET, transmitted wave, ER or reflected wave. Okay, now second I do the calculation for the reflected wave. Okay, so number 2, ER, reflected wave. So again I have to apply the simple trigonometric concept that I have to apply for the incident wave. So you will get here, it is ERO for the reflected wave cos theta r AX minus ERO sin theta I AZ. Apply the same trigonometric concept. Okay, how can you apply it? We will quickly see it. Okay, see here, it makes how much angle? It makes theta r. Okay, these two lines are perpendicular. Okay, it makes theta r angle. So which angle is theta r? You can say this angle is theta r vector. So this one is 90 degree minus theta r. So this angle is theta r. Okay, so this component is ERO cos theta r in x direction, and this one is ERO sin theta. Okay, in which direction? In minus z direction. Okay, so you can write in this way. And number 3, transmitted wave ET. Okay, again see here for the transmitted wave. Okay, this angle is theta t angle. So I have to apply this concept. Okay, so this theta t angle. So which angle is theta t? This angle is also a theta t angle. It makes theta t angle. Okay, so this one is pi by 2 minus theta t. So this one is also theta t. Okay, so this part is ET cos theta t in x direction, and this one is ET sin theta t in which direction? In minus z direction. Okay, so we can write in this way. It is ET is equals to ET0 cos theta t in x direction minus ETO sin theta t in z direction. Okay, so this is known as parallel polarization. Parallel polarization means electric field is parallel to my xz plane. What about the magnetic field? Magnetic field is perpendicular. Okay, but actually the polarization is depend on electric field. Okay, so this parallel polarization means the electric field is parallel. Okay, actually it is in any direction, but it is parallel to my xz plane. Clear? So now based on that, I have to write the equation for incident magnetic field, reflected magnetic field, and transmitted magnetic field. Okay, so what is the relationship between electric field and magnetic field? We will know relationship between electric and magnetic field is E is equals to eta into H. Okay, where eta is intrinsic impedance. Okay, so first I have to write equation for HI, incident magnetic field, then reflected magnetic field, and last transmitted magnetic field. Okay, so what is H? H is equals to eta by, sorry, E by eta. Okay, so here EI is equals to this one. So what is H? HI is EIO upon in which medium? Incident electric field is in which medium? This one is my medium 1 and this one is my medium 2. So incident electric field is medium 1, reflected field is in medium 1, and transmitted field in medium 2. Okay, so HI is equals to EIO by eta 1. In which direction? Here we assume magnetic field in y direction, so this in AY. What about the reflected field? The reflected field in minus y direction, so this minus ERO by eta 1 AY. And what about the transmitted field? The transmitted field in the same y direction, positive y direction. Okay, so this ETO by eta 2 into AY. Okay, why it is negative? That we have already discussed. Okay, because the polarization direction is nothing but the cross product of E cross H. Clear? So that is why I have to take is a negative sign. Clear? So now what we have to do in this theory, we have to derive the equation for transmission coefficient and reflection coefficient, and we will also discuss about what is the Brewster angle. Okay, so now I have to apply boundary condition, at which plane? At z is equals to 0 plane. At this plane I have to apply the boundary condition for electric field and boundary condition for magnetic field. Okay, we know that the boundary condition for electric field is E tangential at first medium is equals to E tangential component at the second medium. Okay, so in the first medium, which component are present? Incident electric wave and reflected electric wave are present in the first medium. In the second medium, only transmitted electric wave is present. Okay, and we have to interested in which component? Tangential component. Tangential component means which type of the component? Tangential means parallel component, parallel to this boundary. It is known as a boundary. Okay, z is equals to 0 plane is my boundary, so parallel to my boundary. So which component is parallel to my boundary? Which component is parallel to my boundary? Okay, so we know that for incident electric wave, EIO cos theta I AX, and for reflected wave, ERO cos theta R AX, this component are parallel to the boundary. That means it is the same direction of X. Okay, so ETO is E tangential 1 is nothing but it is EIO cos theta I plus ERO cos theta R is equals to which component is tangential to the boundary for the transmitted wave? ETO cos theta T. Okay, so it is ETO cos theta T. Okay, so now I have to apply Snell's law. What Snell's law say? That incident angle is exactly equal to the reflected angle. Okay, so if I have to apply the Snell's law, so it is EIO plus ERO cos theta I. Why I have to apply the Snell's law? And according to the Snell's law, theta I is equals to theta R. So give it equation number 1. It is equation number A. Okay, now so it is a first boundary condition for electric field. Similarly, the first boundary condition for magnetic field is same, H tangential component is equals to H tangential 2 component. Okay, so which component? Okay, which components, which tangential component is present here? So I can write in this way. So here it is EIO by eta 1. Okay, this one EIO by eta 1 minus there are two waves are present in medium 1, ERO by eta 1 is equals to it is ETO by eta 2. Okay, so actually this component are in the y direction, but it is tangential to the boundary. Okay, see here, actually magnetic field in the y direction, but it is tangential to the boundary. Tangential means it is parallel to this boundary. Okay, see here, I have given an example. This one is the x direction and y direction. What about this vector? This vector is in which direction? Okay, this vector in the minus x direction. But this vector is present in which plane? This vector is present in xy plane. This vector is parallel to the xy plane. What about this vector? This vector in the positive x direction, but the vector is still present in xy plane. Okay, so similarly, actually magnetic field is present in the y direction, but here L is equals to 0 plane is my boundary. Okay, so throughout this boundary, if so the component which is present in x direction and component which is present in the y direction are parallel to the boundary. Okay, so we can write in this way. So it is EIO minus ERO is equals to eta 1 by eta 2. It is intrinsic impedance ETO. Okay, so this is second equation number B. Okay, now to just do the addition of these two equations. Okay, so add a plus b. I do the addition of these two equations. Okay, so if I do the addition, cos theta I, so this cos theta here, so if we do the addition, so this 2 EIO is equals to ETO cos theta t divided by cos theta I plus intrinsic impedance of first medium, intrinsic impedance of second medium into ETO. Okay, you can write in this way. Clear? So ETO is common, so it is 2 EIO by ETO is equals to, do some simple mathematics, this N2 cos theta t plus N1 cos theta I divided by N2 cos theta I. Okay, so the equation is look like this. So now it is, I will just rearrange this term. Okay, so this EIO by ETO is equals to N2 cos theta t plus N1 cos theta I divided by N2 cos theta I. Okay, it's 2 times. So what is ETO by EIO? Is a transmitted wave to the incident wave, which is nothing but my transmission coefficient, which is denoted as small tau. So small tau is equals to ETO by EIO, which is equal to 2 times N2 cos theta I divided by N2 cos theta t plus N1 cos theta I. Okay, so finally we will get the equation of transmission coefficient. Okay, so this is the equation of transmission coefficient. Now we know that relationship between transmission coefficient and reflection coefficient. What is the relationship between transmission coefficient and reflection coefficient? Now by the relation 1 plus capital tau is equals to small tau, where capital tau is reflected coefficient, small tau is transmission coefficient. Okay, so capital tau is equals to small tau minus 1, this one minus 1. Okay, this equation minus 1. So N1 cos theta. Okay, so this cancel out, so you can write in this way, N2 cos theta I, one term cancel out, so minus N2 cos theta t divided by same term, but here it is positive sign, N2 cos theta t. It's not N, but it's a reflective, sorry, it's a intrinsic impedance. Okay, it is eta, it's not N, but it is eta. So this one is equation of reflection coefficient. Clear? Okay, so we will get 2 equation for transmission coefficient and a reflection coefficient. Okay, I just do some slide mistake. Here it is N1. Similarly, here it is. Okay, so generally, what is the equation of tau for normal incidence? Okay, for normal incidence, the equation of tau, okay, that we have already discussed. For the normal incidence, the equation of tau is N2 minus N1 upon N2 plus N1. And what should be the equation for small tau transmitted coefficient, which is 2N2 divided by, actually it's not N, it's eta, eta 2 by eta 1. Okay, so here these terms are extra, theta, cos theta I, cos theta t, cos theta I, similarly cos theta I minus cos theta t, cos theta I plus cos theta t. Okay, so I will just compare this equation. Okay, so this equation is valid when it is a reflection of uniform plane wave at normal incidence, and this equation are for reflection of uniform plane wave at oblique incidence. But when the first case is when it is parallel polarization, then these two equations are valid. If it is perpendicular polarization, so the equations are slightly changed, that we will discuss in our next lecture. Okay, so now now how to analyze this equation. So when tau is 0, now the question is when tau is 0. Okay, now it is a question mark. Tell me when the tau is 0. Tau is 0 when n2 cos theta I minus n1 cos theta t is equals to 0. Okay, if the numerator, because see at the numerator term is a negative sign. Okay, so there is a possibility that the value of tau should be 0 in some cases for the some angle. Okay, so when the tau is 0, the tau is 0 when n2 cos theta I is equals to n1 cos theta t. Okay, under this condition the value of tau is 0. Okay, so what do you mean by tau is equals to 0? Tau is equals to 0 is indicate that reflection is 0. Okay, tau is 0, that means reflection is 0. Okay, so this reflected wave is 0. Tau is 0, that means the reflected wave is 0. So whatever the incident wave, will get the totally transmitted wave. So in that case the reflected wave is 0. Okay, so now we have to find out at which angle, okay, at which theta I angle the incident wave is totally transmitted, or you can say in another word, at which incidence angle the reflected wave is 0. I repeat, at which incidence angle the incident wave is exactly equal to the transmitted wave, or you can say that at which incidence angle the reflected wave is totally 0. That we have to find out this theta I angle. Okay, so this angle is known as the Brewster angle. Okay, so this angle is known as Brewster angle. It's a Brewster angle, and it is known as theta b. Okay, so Brewster angle, that means capital tau is equals to 0. Capital tau is equals to 0, that means no reflection of wave. Okay, no reflection of wave, that means total transmission. No reflection of wave, or you can say that it is total transmission of wave. That means the wave is totally transmitted. So it's a total transmission of wave. That we have to find out this Brewster angle. Okay, so how to use this equation? Now how to apply our mathematics knowledge. Okay, so this and square. Okay, how to take the square on the both side and to square cos theta I. Okay, I have to find out what is the incident angle, and it is nothing but the Brewster angle. So cos square theta b, I have to just replace theta I with theta b. Okay, is equals to eta 1 square cos square theta t. Okay, it is eta. So eta 2 square 1 minus sin square theta b is equals to eta 1 square 1 minus sin square theta t. Okay, so you can write in this way, 1 minus sin square theta b. We have to find out what should be the value of theta b, Brewster angle. Okay, eta 1 by eta 2 square 1 minus sin square theta t, where theta t is transmitted angle. Okay, so now we have to find out the value of this theta t, then I have to put here. Now we have to apply the Snell's law. We know that second Snell's law, which is nothing but by using the concept of Snell's law, it say that n1 n1 sin theta I is equals to n2 sin theta t. Okay, where n1 and n2 is refractive index. Okay, so here sin theta t is equals to n1 by n2 sin theta I. Okay, so sin theta t is equals to, what is n1? N1 is under root of mu1 epsilon 1. What is n2? Under root of mu2 epsilon 2 sin theta I. Theta I means the Brewster angle. Okay, so this is my equation number C. I have to put this equation here. Okay, sin square theta t. I have to put the value of sin theta in this earlier equation. Okay, so if I have to substitute the value, then it is 1 minus sin square theta b, 1 minus sin square theta b is equals to, okay, now it is not n1, it is intrinsic impedance eta 1. So we know that what is eta 1? Eta 1 is equals to under root of mu1 by epsilon to 1. Okay, so eta 1 is mu1, it is under root and it is square, so this, okay, again see this, if, okay, so this eta 1, eta 2, okay, is it correct? Yes, eta 2 square and 1. Okay, so sin square theta b is equals to this one, sin square theta b, yes, it is correct, 2, so n1 by n2. Okay, so what is eta 1? Eta 1 is under root, okay, so this mu1 by epsilon 1, and what is eta 2? Mu2 by epsilon 2. Okay, clear? And 1 minus sin square t, so this 1 minus this term, which is mu1 epsilon 1 by mu2 epsilon 2 sin square theta beta. Okay, so sin square theta b terms, sin square theta b terms. Okay, so you can write in this way, 1 minus sin square theta b term is equals to mu1 epsilon 2 by epsilon 1 mu2 minus, it is mu1 square, okay, it is mu1 square by mu2 square sin square theta b term. Okay, so if you rearrange this term, okay, so it is 1 minus mu1 epsilon 1 by mu2 epsilon 1 is equals to 1 minus mu1 square by mu2 square sin square theta b. Okay, so what is sin square theta b? So sin square theta b is equals to 1 minus mu1 by mu2 square divided by okay, so not sorry, so what is sin square theta b? So sin square theta b is equals to 1 minus mu1 epsilon 1 upon mu2 epsilon 2. Okay, it is mu1 epsilon 2 divided by 1 minus mu1 by mu2 square. Okay, and if you remove this square, so this is under root. Clear? So it is nothing but the calculation of the Brewster angle. Okay, so what do you mean by the Brewster angle? The Brewster angle means there is no reflection, it's a total transmission of wave. Okay, there is no reflection, it is a total transmission of wave, it is known as the Brewster angle. Okay, and this one is the equation of transmission coefficient and reflection coefficient when it is parallel polarization of wave. Okay, so here we have finished the discussion of parallel polarization of wave. Now again we will quickly revise what we have to do in our today lecture. In today's lecture we will discuss about the What is parallel polarization wave? What is parallel? Parallel means here electric field is parallel to the which plane? It is parallel to the axial plane. According to that, we have to derive the equation for EI, ER and ET. Based on that, we have to derive the equation for HI, HR, HT. I have to apply the boundary condition. Tangential component are same. Okay, I have to just add these two equations, and finally we will get what is transmission coefficient and what is the reflection or what is the reflection coefficient. Okay, so now in next lecture we will discuss about the perpendicular polarization of wave. Okay, thank you.